Today, let's discuss vehicles with nuclear propulsion. Sounds absurd? Well, it is. But listen to me, because this is a really fascinating subject. We are aware of Elon Musk's strong stance in favor of nuclear power. We are aware that nuclear power is a safe and effective way to generate electricity. And we are aware that a tremendous amount of electricity will be required if Tesla and Elon Musk are to succeed in bringing about the global transition to sustainable energy. The building up of enormous numbers of batteries that we can use to store energy from environmentally friendly but occasionally erratic sources like solar and wind is one way to achieve that. But what if we could generate a steady stream of green electricity as opposed to constantly gathering and storing energy like a chipmunk? Imagine a self-charging electric vehicle that doesn't require batteries or recharging. What if a nuclear-powered world isn't just a 1950s science fiction fantasy? Could it be the new secret to a future with sustainable energy? Let's find it out in this video. The future automobile. Fortunately, the 1950s showed us what a nuclear-powered car would look like, so we don't even need to imagine it. America in the 1950s must have been one hell of a time to be alive. There is no reason why we shouldn't be living in the Jetsons world right now, as evidenced by the overt optimism and grandiose visions for the future in which everything is automated, electrified, and powered by clean atomic energy. And that's a little irritating. Anyway, this is what Ford thought. The 1958 Nucleon concept car was the nuclear car of the future. Unfortunately, they never built anything larger than the 3/8 model. But the idea is that there would be a nuclear fission reactor in the back that would power an electric motor. Each micro-reactor would last for approximately 5,000 miles before needing to be replaced with a new one. Therefore, you would receive a reactor change as opposed to an oil change. The 1958-born Studebaker Astral is another excellent model. The atomic energy that propels this one-wheeled vehicle creates a force field that shields it and enables it to fly through the air and even into space. It also has gyroscopes for stabilization. Those ideas, of course, never materialized, but it was possible to create vehicles with nuclear power. These are real. The first nuclear-powered submarine to be launched was the USS Nautilus in 1954. Two steam turbines on board the ship were powered by an onboard nuclear fission reactor, which produced over 13,000 horsepower for the propulsion system and over 13,000 horsepower for the ship's electrical systems. This represented a significant advancement in submarine technology and allowed Nautilus to remain submerged indefinitely. Before this, they mostly worked like regular boats that could briefly go under the water but had to stay above it the rest of the time. The NS Savannah was the first commercial ship in the US to use nuclear power. It set sail in 1959. Dwight Eisenhower began working on this initiative in the middle of the 1950s. The president wanted to demonstrate to the world that atomic energy could be used for peaceful technological advancements that would benefit humanity. The Savannah served as a showcase in a larger campaign to show how atomic energy could be used peacefully for things like food preservation. That is real, yes. It's not as stupid as it sounds either. It turns out that irradiating food with ionizing radiation from gamma rays and X-rays does not harm people or transform them into the Incredible Hulk. When I googled that, I had expected to read about how everyone had developed cancer. The more you know though, the better you will be at eliminating the microorganisms that result in food spoilage and foodborne illness. Anyway, it was all great, and everything functioned as it should have. Simply put, it was too damn expensive. Savannah's 1959 construction cost $47 million. Since there have been approximately 1,000% inflation since then, the equivalent in current dollars would be over $478 million, which is just below the price of Jeff Bezos' super luxury yacht that is so large it cannot fit under a bridge and is currently stranded in Rotterdam. Then why shouldn't modern technology be able to scale that down to the level of powering a car if a nuclear reactor could power a boat in 1959? You might assume so, and the response is that we can, in a way. The term small modular nuclear reactors, or SMNR, has gained popularity in recent years. Testing of the new technology was supported by President Trump in late 2020 with a $1.4 billion Department of Energy grant, and President Biden continued this support by approving the construction of the nation's first SMNR in 2021. Though they haven't finished it yet, they are working on it. Previously in 2018, NASA created a small modular fission reactor prototype that may one day be used to power a lunar base. Being only about 1.5 feet across and about 3 feet long, NASA's Project Kilo Power reactor was very small. In fact, it probably would have been a good fit in the Ford Nucleon's back. So, is this the nuclear power plant of the future that was envisioned all those years ago? Well, the NASA prototype only produced 1 energy or 1.3 horsepower. So I'd have to disagree, and that is regrettable. I could still push a car faster than any reasonably sized nuclear engine could move it after 60 years of technological advancement. There is such a large gap between where we are and where we need to be that no amount of innovation is likely to be able to close it anytime soon. Simply put, it won't happen. Of course, that's before we consider how safe it all is. Unfortunately, Studebaker's energy force fields were a failure, making it very challenging to stop a Chernobyl-level nuclear catastrophe every time there was a significant automobile accident. Without entering a nuclear winter, the human race couldn't even make it through one Los Angeles rush hour. Okay, so it's probably not a good idea to have a nuclear reactor in a car. I apologize if that disappointed you. However, we do have some suggestions for a potential middle ground resolution, and this actually connects to Elon Musk and SpaceX. A group of former SpaceX engineers formed the company Radiant, which is in the business of creating incredibly powerful micronuclear reactors. The concept is to create a lightweight, affordable, and portable zero-emissions power source the size of a shipping container. In 2021, the business raised more than $1 million in funding, and as of now, it has prototyped a microreactor that is already producing 1 megawatt of energy, which could power 1,000 homes for up to 80 years. Now, before we get any deeper into this interesting topic, please give a thumbs up if you are enjoying this video so far, and stay tuned until the very end to find out if nuclear energy can really power Tesla cars. So, here's the thought. Could a Tesla be recharged with a nuclear reactor if you can't use one to power one? It's hard to imagine why there couldn't be one at every Tesla supercharger station, or 2, or however many are required if these things are inexpensive and transportable as they're made out to be and only have the footprint of a shipping container. This fixes 2 significant issues with electric cars. Grids with dirt are first. Even if your car doesn't emit carbon dioxide, it's still a problem if the electricity you use to charge it comes from a local power grid that burns coal. No matter where your electricity comes from, EVs will always have a much lower carbon footprint than ICE vehicles. But it would obviously be better with green electricity. When we discuss electric cars, the number 2 complaint is a common one that I hear. What happens if the power grid fails? They would be lost if there was no electricity because they couldn't recharge the car. With that one, it's difficult to disagree because they do, in part, make a valid point. However, if you set up a small nuclear power plant at the charging station, the issue will be resolved instantly. But is it safe? Contrary to what many people think, nuclear energy is actually very safe and non-polluting, which is why Elon Musk is such a fervent supporter of it. People may believe nuclear power plants produce pollution because of the enormous hourglass-shaped stacks that are constantly spewing gas from them, in my opinion. Actually, this has a lot to do with The Simpsons. But nuclear power doesn't use combustion. Water evaporates as a result of the reaction's heat, producing steam that spins a turbine. Water vapor is the only byproduct that is released. Therefore, those are steam stacks rather than smokestacks. Then there will be the meltdown. If you know how about Chernobyl, you know that the disaster at 3 Mile Island was mostly caused by mistakes made by people. Extremely similar deal Fukushima was the only one that wasn't directly preventable by anyone on the ground at the time. However, we can use the lessons we've learned from that catastrophe to design more resilient nuclear systems that, in the worst case scenario, wouldn't suffer the same fate. Utilizing trisomy 11 particle fuel, also known as the most durable nuclear fuel on Earth, Radiant is already addressing the meltdown problem. According to Radiant, the reactive material is made up of tiny fuel grains enclosed in capsules the size of poppy seeds. These granules won't melt and would be easy to scoop up if they were to fall to the ground. They additionally use radioactive-free helium coolant. A helium leak would therefore be insignificant in comparison to leaks from older water-cooled reactors, or even more recent molten salt reactors, which could still be dangerous and contaminate the ground. I believe that after all of that, we actually arrived at a pretty sound conclusion. No, despite how much we would like to be able to power each and every car with a nuclear reactor, however, we could design self-sufficient, zero-emission nuclear charging stations using state-of-the-art microreactor technology. And that would be really, really awesome. What do you think? Do you support nuclear power? Please share your opinions in the section below. And that's it for today. Thanks for watching. I'm Fred. Please subscribe to our channel for more technology updates, and like and share this video. Now, do you know that Ford introduces a new LFP battery? To know more, click and watch the next video here.